Okay, welcome back. We are now going to move into talking about confidence intervals. So, this is part of the reason why we had to look at sampling distributions and look at normal distributions because they're going to really help us understand what a confidence interval actually is. And I think this section should be a little bit more intuitive since confidence intervals are, you always make them when you have some real data. And so let's just jump right into what the definition of a confidence interval is. And we're really just thinking about a confidence interval as a range of either like plausible or reasonable values for an unknown population parameter. And so this next section will be all about how we're actually going to calculate this range of reasonable values and how to interpret it as well. The standard error, we actually saw this on StatKey a while back. This is just a term for the standard deviation of the sampling distribution. All right, so just because we don't always want to say standard deviation of the sampling distribution, that's a bit of a mouthful. It gets its own term because it gets used so much as well, called standard error. What this really does is guides how wide our confidence interval should be. As we'll see through examples, a higher standard error is going to mean our confidence interval is going to be wider. So we're going to be less certain about where our population proportion is. Combining these, our confidence interval for any point estimates, remember this was, so far we've just done proportions, so this is our p hat. So when that follows this normal distribution, so when the sampling distribution is approximately normal, like we talked about with the central limit theorem condition, then a 95% confidence interval can be constructed as our point estimate. So again, that's like our best guess, so that is going first, plus or minus 1.96 times the standard error, which I'm going to abbreviate as SE. Putting this into the notation we've been using, our point estimate is p hat plus or minus 1.96 times the square root of p hat times 1 minus p hat divided by n. So remember, this came from that earlier formula, the standard deviation of our sampling distribution on page 10. But instead of p, we're just throwing in p hat because we don't know what the population proportion is. And so again, we're just throwing in our best guess for p in the standard error formula as well. So all we really need for our confidence interval is we just need our sample proportion and we need to know the sample size. We'll talk in class about where this 1.96 comes from, and we'll kind of pick up here next time when we meet in person. As always, definitely feel free to reach out if you have any questions about any of this stuff.